Here on day 7, we're talking about kites. These are all special kinds of quadrilaterals that we're studying. And as you take a look at the shape, you can see obviously they are not parallelograms. They have some very different properties. So before we get to those blanks right there, one thing we want to point out is that there is a single line of symmetry that runs along the long diagonal. You can see the long diagonal drawn in here on the right-hand figure. On the left, it's not drawn in, but that's the one and only line of symmetry. So you can reflect this sort of top triangle over to the bottom triangle there. And what that means for us is that this side is congruent to this side. So notice in the parallelogram we had opposite sides were congruent, but that's not what we see here. Here we see consecutive sides are congruent, and that happens not just with this pair, but we have a second pair. So it's kind of a strange way to word this. We say a kite is a quadrilateral that has two pairs of consecutive congruent sides. So the consecutive sides have to be congruent, but at the same time, the opposite sides are not congruent. You can see that the opposite sides are different sizes. So that's the definition of a kite. This also means, when we do this reflection, if we reflect this top triangle down here to the bottom triangle, it also means that this angle at A is congruent to this angle at C. So we can observe it has exactly one pair of congruent angles. It doesn't have two pairs like we saw in the parallelogram. So we'll jot that down here in point 3 in just a moment. Point number 2 is talking about the diagonals. So go over here to this right-hand diagram. It turns out the diagonals are going to be perpendicular. So once again, we have a right angle, which means that each of these 4 triangles that are formed by the diagonals are right triangles. So whichever right triangle you use, they're all right triangles. And remember, if they're right triangles, then we can use our Pythagorean theorem, right? So a squared, b squared equals c squared, right? So just remember that idea, and we'll be seeing an example of that in just a moment. That's true for all of our right triangles. So the hypotenuse is going to be that outer side of the kite. That's what we're seeing here on number 2. It says if a quadrilateral is a kite, then its diagonals are perpendicular. And using this diagram specifically, we can see that the diagonal from A to C is perpendicular to the diagonal from B to D. There's our right angle, and we get those right triangles. So then this third point is talking back in this diagram here about those opposite angles. Remember, it's not 2 pairs, it's only 1 pair. So the way it's worded, it says, if a quadrilateral is a kite, then exactly 1 pair is congruent, right? Exactly 1 pair of opposite angles is congruent. So those are the main properties. Let's look at a few examples. Here's example number 1. In this section, we're trying to find the measure of angle C. There it is. That's what we want to know. So observe that we do have 2 of the 4 angles, but we're missing the other 2. So the trick is to recognize that we have a line of symmetry that runs along the long axis, right? That means that this side on the right is congruent with this side on the left, right? So you're reflecting it from right to left. This side on the right is congruent with this side on the left. So those tick marks there are also helping you to identify that the line of symmetry runs up and down. It does not run side to side, because you can't reflect a single tick mark over here and have it land on a double tick mark. Now it has to go this way. That means that these angles are also reflected. So you have 2 congruent angles. Those are the same size. So let's pick a variable, and if one is the size of x degrees, then they're both x degrees. And we will add all of these up, all of these angles up. X plus the 84 plus the other x plus the final angle of 140 degrees. They all add up to 360. Now, you might remember we studied that. We learned that any quadrilateral has its 4 angles add up to 360. So that's something that we've seen a few days ago. We're going to combine like terms. 1x plus 1x is 2x. 84 plus the 180 is 224. Let's move the constant terms to the right. We're subtracting 224 from both sides. So we have 2x on the left and 136 on the right. So dividing away the 2 to isolate the variable, we get 68. So the measure of angle C is 68 degrees. So notice that the variable x is 68. It does not have the degree symbol because that is just a variable, but the angle measure does have the degree symbol because angles are measured in degrees. There's your final answer. So if you jump down to the you try problem right below that here on number 3, see if you can find the angles of the kite. All right, so pause the video, work this example out. We'll come back shortly and check the answer. So with this problem, notice where the line of symmetry is. This is your long axis. This is the line of symmetry. So that's how we know that the 105 degrees that you see at the top will also be found here at the bottom, because we'll take this top half of the kite and reflect it across the line of symmetry. And so both angle B and angle D are 105 degrees. So then for the last missing angle, we'll create a variable and then add up all 4 angles to 360 degrees. So it looks like this. We get an answer of x is 130. Again, that's the variable. So the angle itself, the measure of angle A is 130 degrees, and the measure of angle D is 105. So there we have 2 problems where we're focusing mainly on the angles. Now let's take a look at a couple of problems where we're focusing on the diagonal lengths and the side lengths as well. So here we are in example number 2. They're asking us to find the measure of angle WAE, so there's an angle in the kite shown, but then we're going to find the side lengths. Now there's 4 side lengths, right? So we're going to find all of them. But if you remember on your kite, 2 of them will be the same, and the other pair will be the same. So really we're just finding 2 different lengths, and then we know all 4. So we have to take a look at what we have here. Here's our short axis. You can see the numbers 3 and 3, so that's a length of 6 on that diagonal. This is the long axis, the long diagonal. 7 plus 10 is 17. So that's the longest diagonal, right? That's your line of symmetry. What that means then is that this top left side will be the same length as this bottom left side, because we're reflecting the top triangle to the bottom triangle. And then from W to T, that will be the same length as ST. So when it says find the side lengths, we could really just find EW, and we'll already know what ES is as well. We need to find WT, and then we'll know what ST is as well. The hint here is just a reminder, hey, what is this angle? Angle WAE, WAE, that's where the diagonals touch. Recall that is our right angle because those are perpendicular. So we're using this idea. You have perpendicular diagonals, you have a right angle, that means you have a right triangle, and we can use the Pythagorean Theorem. That's what we're doing here on example number 2. So let me outline this. That might help to see what we're looking at here. So this is the triangle that we're using. So if I were to draw that again, just to kind of clarify what we have a 3, we have a 7. That's the hypotenuse we're trying to find. Always give the C to the hypotenuse. So let's use our Pythagorean theorem. That will be 3 squared plus 7 squared equals the hypotenuse squared. 9 plus 49 will add up to 58. And then to get C by itself, we need to take the square root of both sides. And my calculator tells me that the square root of 58 is going to be about 7.62. So we're rounding there. So what that means is the length from E to W is 7.62, and the length from E to S is also 7.62, like that. But now we have to work on the right side here. So that means we have another right triangle. Let me outline that, like so. Just redrawing that triangle. There's the right angle. The height is 3, the base is 10, And the hypotenuse is what we have to find, right? So once again, Pythagorean Theorem, a squared plus b squared equals c squared. So 3 squared plus 10 squared equals my c squared. 9 plus 100 is 109. And then we'll take the square root of both sides. So there's its exact length, but as I go to the calculator, 10.44 is that result. So this is a length of 10.44 from W to T, and then from S to T, that is also a 10.44. All right, so again, I want you to try it. Find the side lengths of the kite shown here in example 4. Notice we have our shorter diagonal going up and down, and the longer diagonal going side to side, so that's your line of symmetry. So the total length of that is 10, right? That's how we know it's longer. Notice that this length that goes up and down, that's not a height of 4, that's a height of 8, because if this is 4, this is also 4. How do we know that? Because of that line of symmetry. One triangle on the top has to reflect down to the triangle below that, or vice versa. All right, so pause the video, see if you can find the missing sides. All right, so here are the results for that last one. You should have side lengths of 4.47 on the left and 4.47 on the left, 8.94 on the top right, 8.94 on the bottom right. Pythagorean theorem for both of those you can see are set up.